polymers. Polymers are macro-sized, high molecular mass compounds. And they are made by the combination of a large number of repeating units. These repeating units are called monomers. So we can say that polymers are made up of a large number of repeating units called monomers, and this process of joining together large number of monomers is termed as polymerization. A polymer formed from only one type of monomer is called a homopolymer. Homo meaning same and polymer. An example of this is PVC. Second type of polymer, which is made from two or more different monomers, is called a heteropolymer. Hetero meaning different. Example is nylon 6,6, very famous example, nylon 6,6. Classification of polymers. The classification can be based on the source, on the structure, on the molecular forces, and on the method of synthesis. So we have four bases of classification. Let us look at our first classification, which is on the source. There are three types of polymers based on the source. Natural polymers, as the name suggests, they are polymers found of natural origin, that is from plants and animals. A simple example could be starch. The second type is synthetic polymers, those that are prepared in the laboratory. An example of a synthetic polymer is rubber. Let's look at classification. Classification can be based on the source, the structure, the forces, and synthesis. Let us look at classification based on the source. They can be of three types: natural polymers, synthetic polymers, and semi-synthetic polymers. As the name suggests, natural polymers are obtained from nature. An example is a starch. Synthetic polymers are obtained in the laboratory. They are called man-made polymers. Example is rubber, Teflon, terylene, etc. Semi-synthetic polymers are those which are derived from naturally occurring polymers by chemical modifications. Example would be vulcanized rubber. To make rubber more hard, sulfur is added to rubber. This process is called vulcanization. Now let us look at the structure. Based on the structure, we have linear polymers, we have branched polymers, and we have cross-linked polymers. Linear, as the name suggests, they are linked together to form linear chains. An example is nylon or polyester. Branched chain polymers are those in which the monomers are joined to form long chains or branches of different lengths. So we have a linear chain, but then we also have branches. And so this is called a branched polymer. A cross-linked polymer are those in which monomer units are cross-linked to form a three-dimensional network. An example is bakelite or melamine. So we have two polymer strands in which the monomer units are cross-linked, and hence we call these a cross-linking polymer. Based on the molecular forces, we have elastomers, fibers, thermoplastics, and thermosetting plastics. In elastomers, the polymers have weak intermolecular forces. The weak forces permit the polymer to be stretched. Thus, elastomers possess elastic character. That is why they are called elastomers. An example is vulcanized rubber. Fibers are the polymers which have strong intermolecular forces. These can be either hydrogen bonding or dipole-dipole interactions. An example is nylon 6,6. Thermoplastics are the polymers in which the intermolecular forces of attraction are intermediate, that is, they are between those of elastomers and fibers. This is intermediate. These polymers do not have cross links. They can be easily molded on heating. A very important property about thermoplastics is that they can soften on heating and become hard on cooling. An example is PVC. Thermosetting plastics have extensive cross links and they undergo a permanent change on heating. An example is bakelite or melamine. And finally, we go to the methods of synthesis. We have two methods of synthesis. The first method is addition, and the second method is condensation. So we have two methods, addition and condensation, which we will see in detail. Let us look at methods of polymerization. Methods of polymerization. My first method of polymerization is by addition. Addition polymerization or chain growth polymerization. An example of an addition polymer would be the formation of polythene from ethene. That is, if I have N ethene molecules and I form polythene. This is ethene, this is polythene. This is an example of a chain growth polymerization or an addition polymerization. Chain growth polymerization follows free radical mechanism. This type of polymerization is initiated by an organic peroxide which decompose to give free radicals. Let us look at the steps. The first step is chain initiation. So I have my organic peroxide. I can write it as RCOO and RCOO. There is homolytic fission and what I get is RCOO radical, which is unstable. So I mention it in a bracket. Since it is unstable, it will undergo fission again, and what I get is CO2 and R radical. Now this R radical is further used in the next step. The second step is chain propagation. The R radical obtained from the chain initiation step now reacts with ethene. I can write ethene as CH2, CH2, and I can show this bond with the two electrons. Now what happens is, again, there is splitting, homolytic fission, in which each electron of the bond goes to one carbon each, and this radical also donates its electron. What we get is R CH2 radical. Now this reacts with another molecule of ethene. So I have RCH2 CH2 radical plus CH2 CH2. As you can see how the electrons are being transferred. product that I get is R CH2 CH2 CH2, and the last CH2 has an electron. And in this way, the chain keeps on growing with the last carbon having the radical. My final step is my chain termination step. In chain termination, two molecules of R CH2 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 radical combine. So I have two molecules of R CH2 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 radical, and my chain terminates, and what I get is R CH2 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 CH2, and then the second molecule, so CH2 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 CH2R. This is my terminated molecule. As I can see, I have two molecules of CH2 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 CH2. That means I should have totally 8 CH2 molecules and 2 R molecules. Termination means there are no more free radicals available. And as you can see in my product, 1, 2, 3, 4, 5, 6, 7, 8 with 2 R molecules and no free radicals, and this is my termination step. Second method of preparation is condensation polymerization. In condensation polymerization, we first need to understand what is the meaning of condensation. Condensation means removal or elimination of a small molecule. A polymer formed by the condensation of two or more monomers with an elimination of a simple molecule like water, ammonia, alcohol is called a condensation polymer. Let us look at an example. I have ethylene glycol, which I can write as OH CH2 CH2 OH. This is ethylene glycol, and I react this with dimethyl terphthalate, that is CH3 OOC, a phenyl ring, COOCH3. This is dimethyl terphthalate. The second method is called condensation polymerization. In this kind of polymerization, a polymer formed by the condensation of two or more than two monomers with the elimination of simple molecules like water, ammonia, alcohol, etc. is called condensation polymerization. Let us directly look at an example. I have ethylene glycol, which is OH CH2 CH2 OH. This is ethylene glycol, and I'm reacting it with dimethyl terephthalate. On heating, ethylene glycol and dimethyl terephthalate, there is an elimination of what you can see, a CH3OH, that is a methyl alcohol molecule, CH3OH, and what I get is terylene. So I write CH2, CH2, OOC, COO n times. Now I have not written the CH3 and the OH is because this CH3 will form another CH3OH with the next molecule of ethylene glycol. And this polymer, which is called terylene, is nothing but a condensation polymer. Some other examples of condensation polymers are bakelite, bakelite is nothing but phenol plus formaldehyde to give us Novolac, and Novolac on heating gives us bakelite. Another very important example of a condensation polymer is nylon 6. A few other polymers. The first one is bakelite. These are examples of condensation polymers. It's formed from phenol and formaldehyde to give us Novolac, which on heating gives bakelite. Another example is nylon 6. It is made up of the monomer caprolactam. And we also have nylon 6,6, which is nothing but adipic acid and hexamethylene diamine. Rubber is a very, very important polymer and it has many, many uses. So let us look at rubber. Rubber is an elastomer. It is obtained from natural sources and the polymers are prepared in the laboratory. And these kind of rubbers in which the polymers are prepared in the laboratory are obviously called synthetic polymers. Natural rubber is a hydrocarbon polymer. It has the composition C5H8N. Destructive distillation of natural rubber gives mainly isoprene. Isoprene is a monomer of natural rubber. Let us look at what isoprene is. Isoprene is nothing but 2-methyl buta-1,3-diene. So let me write what isoprene is. It is 2-methyl 1,3, 2-methyl, this is carbon 2, 3, 4. 2-methyl 1,3-butadiene. It's called isoprene. Isoprene on polymerization gives me natural rubber. That is many isoprene units linked to each other is natural rubber. Vulcanization is a very important process in which rubber is treated with 3 to 5% of sulfur. When sulfur is introduced, what happens is that the tensile strength, elasticity and resistance to abrasion increases. And hence vulcanization is a very important